calculus this far, we have been finding derivatives by taking the limit as h approaches 0 of the difference quotient. Today, I'm going to teach you some shortcuts that you're going to like much better. But remember, if it ever asks for the definition of a derivative to find the derivative, then you must use the limit as h approaches 0 of the difference quotient. So, first shortcut, if you have x to the n, that's going to be n times x to the n minus 1. For example, if y equals 2x cubed, y prime will be, keep your 2, move your 3 out front, and subtract 1 from your power. So, y prime is 6x squared. Another example, x to the 4th, the derivative will be 4x cubed. Derivatives of a constant. If you have a derivative of a constant, it's equal to 0. Remember that the derivative is the slope. What's the slope of a constant, otherwise known as a horizontal line, is 0. For example, f of x equals 4, dy dx will be 0. No matter the number, 4, negative 8, 12 million, if it's a constant, its derivative is 0. Constant multiple rule. This is one where the constant stays out front. So you keep the constant, it's really the derivative of the function. Or c times f prime of x. So for instance, on this one, f prime of x, keep your 3. The derivative of x to the 5th is 5x to the 4th. So our derivative is 15x to the 4th. And you might not always need to show this middle step. In order to do it, as you get the hang of it, you'll be able to do it in one step. Sum or difference rule. Simply derive the first term, keep the same sign, derive the second term, and you're done. So, 3 times 5x to the 4th minus 4 times 2x to the 1st minus 7. And the 7x is 7x to the 1st, so it becomes 7x to the 0, which is just 7 because x to the 0 is 1. And we get 15x to the 4th minus 6x minus 7. And again, eventually you won't have to show this step. You'll be able to go directly to the derivative. Now, when we have a product, we have a special rule called the product rule. We have to take the first function times the derivative of the second function plus the second function times the derivative of the first function. Or f times g prime plus f prime times g. Remember that it is always a plus sign in the middle, not a negative, always a plus. For example, using the product rule, f prime of x, we take the first times the derivative of the second, which is 28x cubed, plus the second times the derivative of the first. Keep in mind, if I at any point am moving too fast for you, you can pause this video to write down what we need. You can rewind and listen to me again. So we end up with 168x to the 6th plus 126x to the 6th, or 294x to the 6th. Just to prove to you that it works, if I were to multiply 6x cubed by 7x to the 4th, I would get 42x to the 7th. When I derive that, 42 times 7 is 294. Subtract 1 from your exponent, and we get 294x to the 6th. Again, because they're the same, that proves that the product rule works. Go ahead and try this example on your own. No, I'll do the one part with you. the derivative of the second, which is just 3. Again, that's a line, so you can think of it as what's the slope of this line, plus the second times the derivative of the first. If we simplify a little bit, 3x squared minus 6x plus 3 plus 6x squared minus 6x plus 6x plus 8x, minus 8. And when we simplify that, we get 9x squared minus 4x minus 5. Pause the video, try FOILing first and then deriving, see if you get the same answer. If you were not able to get the same answer, come with questions to class tomorrow. The quotient rule, a good way to remember it, if you think of this as the low and this is the high, the denominator your low, the numerator your high, low d high minus high d low, draw the line, square the low. So, low d high minus high d low, draw the line, square the low. Or shorter yet, as an abbreviated description of that rule. Let's try one. Low d high minus high d low, draw the line, square the low, which gives us 6x minus 4 minus 6x plus 15. Distribute your negative, combine like terms, and we end up with negative 19 over 3x minus 2 squared as our derivative using the quotient rule. Take a second, pause the video and give this next part A a try. Hopefully you ended up with negative 5x plus 2 all over x cubed. Now let me show you another way we can do it. Dividing first. So dividing first means g of x equals x squared over x squared plus 5x over x squared minus 1 over x squared. If I simplify this a little bit, I get 1 plus 5 over x minus 1 over x squared. I'm going to rewrite these slightly. I have not started to divide yet, or derive yet. I'm just getting ready. So, rewrite them all in the numerator. The derivative of 1, a constant, is 0, so I'm not going to put anything. The derivative of 5x to the negative 1 is negative 5x to the negative 2. And the derivative of negative x to the negative 2 is positive 2x to the negative 3. Or, and if we do a common denominator, multiply by x over x, we get negative 5x plus 2 all over x cubed, which is the same thing that we got when we did the quotient rule. So there's proof for you that it works. If you need to, watch this video again to catch on to those tricks, and we'll see if you remember what to do tomorrow. Come with questions if you have them.